So we'll move on to the next problems and pentagonal prisms. I'll take this problem number 20 in KRG, Gopal Krishna. I'll go for 21. A pentagonal prism of 25 mm side of base and height 50 mm rests on one of its longer edges on HP such that one of the rectangular faces containing the longer edge on which the prism rests is inclined at 30 degrees to HP and nearer to the observer. The axis of the prism is inclined at 40 degrees to VP. Draw the top and front views. So we'll go for the 21. A pentagonal prism of 25 mm side of base and height of 50 mm rests with one of its longer edges on HP such that one of the rectangular faces containing the longer edge on which the prism rests is inclined at 30 degrees to HP and is nearer to the observer. The axis of the prism is inclined at 40 degrees to VP. Draw the top and front views. We'll see how to solve this problem. And again, I'll explain different conditions in this and other problems what they can modify in this, other conditions what they can modify in this problem also discussed today. So it says a pentagonal prism resting on one of its longer edges on HP such that one of the rectangular faces, it says, containing that longer edge on which the prism rests is inclined at 40 degrees to HP. So we'll go for that. I'll just explain the condition before we go for solving the problem. So say this is a pentagonal prism. It says it's resting on one of its longer edges on HP. So in that particular problems, so if you want to keep the longer edges resting on HP, and you can have actually two types of problems where it can say prism is resting on one of its longer edges on HP, or you're going to have some problems where he says it's resting on one of its rectangular faces on HP. So one of its longer edges on HP or rectangular surfaces on HP. In that case, actually you can go for a regular method, a 3 steps method, where you can keep the lamina something like this on HP. Then you completely bend, so the corner position. So when you bend this completely, so then it will going to rest on this longer edge which is on the right side. Okay, so this is the one, so resting on the longer edge. And he says the axis is inclined. There is one more condition given. He says in this case when you keep in this way, so the rectangular surfaces containing this longer edge, there will be two rectangular surfaces. They make actually equal inclination with HP, but in that one the rectangular surface should be at 30 mm HP. In that case you have to go for drawing a line something like this at 30 degrees. Then you have to go for bending that. He says it's towards observer, so I'm keeping it towards observer at 30 degrees to this. Then in the same position, if I bend, it will going to rest on that longer edge. Then the axis inclination, because the axis is now parallel to HP, because the longer edge is resting on HP, because the axis in the prisms will be parallel to the longer edges. So because the longer edge is resting on HP is nothing but it's parallel to HP, so the axis will be also parallel to HP. So then it will be in the true length. So then you can go for giving inclination to VP, the given inclination. So then that will be the completion. So these are the 3 steps then. Okay. So 1, so bending that to make it horizontal in the second step, then inclining that to axis to make inclination with VP. So in this case, axis perpendicular to HP parallel to VP. Now it is becomes parallel to both the planes. Now keeping it parallel to HP, it will go to, because it has to, keeping it parallel to HP is nothing but you have to have this longer edge resting on HP, so it will be always parallel to HP. Now we have to give the inclination to the VP. So since it is parallel to HP, it will be in the true shape, so you can directly give the inclination, no need to take beta in this case. So these problems can be solved by one more method that you cannot actually use in case of pyramids. So where I can keep the solid directly in VP. In that case, I'll show you. If this is in VP, say if this is VP, so then I can keep this longer edge resting in, see, on HP. So in that case, if it is resting on HP, something like this, sorry, resting on HP, so then we'll see that in the vertical plane, so this is HP, I'm turning actually HP to like this. So in that case, the longer edge will be now resting on HP. So when you keep the lamina to lie on HP like this, in that case, since this end faces will be parallel to VP, I can directly draw the view in VP, keeping it something like this. So longer edge, so touching XY line, because this XY line now represents, when you are looking at this vertical plane, so HP, because VP and HP will be mutually perpendicular, so now this will be the HP, because VP, I'm looking at VP, so these are mutually perpendicular. When I am looking at HP, so then this will be the vertical plane. So the XY line represents the vertical plane. In that case, I can say this, one of its edges is perpendicular to vertical plane, because this is vertical plane and this becomes horizontal plane. Whereas when you are looking at VP, so this becomes horizontal plane, whereas this is the vertical plane, right? Okay. So in that case, if I keep the lamina in VP something like this, making this longer edge touching this XY line is nothing but it's horizontal plane. Now when you're looking at this, so VP and this is HP mutually perpendicular, then I can directly draw this view polygon, any prism, so that I'm going to have a corner of the polygon touching XY line is nothing but the longer edge containing that corner. So we're going to have a corner that represents a corner, because when it is resting on HP, so this line will be perpendicular to VP, right? Okay, it's perpendicular to VP. So in that case, we'll see that. So this is the longer edge resting on HP. So these are the two rectangular surfaces. He says they make equal inclination with VP. If it is 108, then it will be 72 divided by 2. 108 plus 72 will be 180 divided by 2. So that is 36. Each will be at 36. But he says it's inclined at 30 degrees to HP. In that case, I have to rotate this to make that inclined at 30 degrees to this horizontal line, so horizontal plane, where this XY line represents actually the horizontal plane. So I can directly go for drawing this in this way. When I look at, when I turn this, say when I go to this position, so this will be the position in the horizontal plane, then this becomes vertical, so mutually perpendicular, so both will be rotating like this. Okay, so when you are looking at the horizontal plane, this is the horizontal plane and this will be the vertical plane. When I turn, so this becomes horizontal plane and this XY line becomes vertical plane. So this plane is now vertical, that's why it's a line. In that way you can imagine. In that case, so this will be the position. So you'll get your rectangle. Okay, so the top view, the height you can see in the top view. So directly you can go for drawing this. You can complete the problem within 2 steps. Okay, whenever you have any prism, saying that it's resting on one of its longer edges, or even if it says when it's resting on one of its rectangular surface, even then you can go for drawing the lamina something like this, drawing that pentagon or any polygon, okay, so where that represent the prism, so something like this, so that it should touch xy line. So this line touching xy line is nothing but because in this view, so this line represent actually the rectangular surface. In that case, you can imagine when you're looking at the front view, so this is your, the xy line is nothing but your horizontal plane. When you're looking at this front view, vertical plane, so horizontal plane will be actually mutually perpendicular. So you'll see that this is actually resting on this horizontal plane. So if I turn that by 90 degrees, so this will be the view in the top, okay, so where vertical plane now will be like this when you're looking at this horizontal plane. So in that case, it will be resting on one of its rectangular surface on HB. So in both the cases, whenever I have any problem saying that a prism, any prism, when it's resting on one of its rectangular faces on HB, or resting on one of its longer edges on HP, you can go for drawing the view directly in VP. So making the edge to rest on XY line, then that becomes rectangular surface resting on HP. Or if you have a corner resting on HP, so that becomes the longer edge resting on HP. Okay. So for this problem, we'll go for drawing this. So if we, in this problem, it says one of its rectangular surfaces containing that longer edge is inclined at 30 degrees. If otherwise, they don't give that. In that case, you can equally incline that rectangular surfaces forming this longer edge. Okay, so these are the two rectangular surfaces forming this line. Equally inclined. In that case, you can go for drawing a pentagon like this. Edge parallel to XY line, then you construct a polygon. So passing through this corner, if we draw a XY line, then that becomes that this corner represent now the longer edge. Okay? So longer edge resting on horizontal plane. Whereas then these two will be equally inclined with the horizontal plane. The rectangular rectangular surface, both will be equally inclined. Whereas in this case, it says it's inclined at 30 degrees. Then you have to turn like this to make one of the edge of this to incline at 30 degrees, so that if I construct a polygon on that, it's nothing but you are satisfying that. I'll keep it on the right, okay, left of this inclination, so that when this becomes like this, because there is one more condition given, he says that surface which is inclined at 30 degrees to HP, the rectangular surface containing the longer edge, that should be near to the observer. In that case, so this is my, on the left side, I will turn so that this comes towards the observer. If it says it is towards VP, then I have to turn in this way, right? Okay, so to give the inclination to the axis. So then I will go for solving this problem. I will go for drawing an edge inclined at 30 degrees. So this edge, what I am drawing, edge of the polygon, will represent actually a rectangular surface, because it says a rectangular surface containing this longer edge on which it is resting, it says is inclined at 30 degrees. So I have drawn that. Then I will go for constructing a polygon, any polygon. If it is a triangle, go for constructing a triangle. If it is a square, construct square, rectangle, pentagon, or hexagon, whatever is given, you can just go for drawing that. So I'll go for drawing the pentagon. Let it be this, a pentagon. So this is A, B, C, D, E. A1, B1, C1, D1, E1. All should be with the dashes because all are front views. This is the front view, all the points. So this is vertical plane and this is the horizontal plane, the first angle projection. Anyway, you have to bisect two of the sides to get the centroid, right? Okay, so this will be the centroid. Now see, this is right. So now when you look at from the top, so I can get this view. the axis. So this is the axis. I'll go for drawing that. So we can keep draw anywhere here. So this is the visible edge. You can reach that edge. You go for making it with a thick line. Then this is visible. So this is, you cannot reach that, so that will be a dotted line. This is visible. Go for making it a dot line. This is visible because you can reach directly the point. So then this will be A, this is B, C, this is D, and this is E. Or I can give this as, because I have taken A1 in the bracket, I'll keep that on the other side. So this is the front surface in that case, A, B, C, D, E. So because A is visible, A1 in the bracket, because I have drawn the bracket there, so I can name this. So anything can be, this can be base or that can be base, no problem in that. Okay. So now all the conditions except the axis inclination are satisfied in this. In that problem it says, see, problem number 21, a pentagonal prism of 50 mm height. So this is the height of 50. Rests on one of its longer edges on HP, so it's resting on B1 longer edge. This corner represent actually the longer edge. Then one of the rectangular faces, out of these two rectangular faces, he says one of the rectangular faces containing the longer edge. So these are the two rectangular faces containing this corner. He says on which it is resting, longer edge on which the prism rests is inclined at 30 degrees to HP. So I made this one of this A1, B1, B is the rectangular surface. Other one is B, B1, C1, C. So I am making this A1, B1, B, this rectangular surface, and inclined at 30 degrees to HP. And he says it's nearer to the observer. So I'll turn like this so that that surface will be nearer to me in the next view. The axis of the solid is inclined at 40 degrees to VP. Draw its projection. So there's the one, right? So in this case, anyway, all the conditions are satisfied. So now the only thing is to incline the axis. Since the axis, now this is the axis, say this is, since the axis is a big dash and a small dash, big and a small, big, small and big. So O and O1, so let it be O and O1 dash. So then the axis, he says, is inclined at 30 degrees to 40 degrees to VP. Draw the top and front views. So this is 30 degrees to HP, he says it's 40 degrees to VP. Now since this axis now is in the true length, I can give the true inclination what he has given. Just you have to turn this solid. So this is the condition I have satisfied completely, making this surface inclined at 30 degrees so that I can see actually in the front view this surface inclined at 30 degrees, so which is resting on HP. Now I can turn in this way so that this A1, B1 will be nearer to me and the axis will going to incline at 40 degrees. So in that case I'll go for turning like this, so that I will just turn in this way, right? Okay, when I turn like this, so I can go for drawing that at 40 degrees a line, the axis line. So then I'll go for drawing a line perpendicular to that, and that I'll just transfer all the distances. Take B to D, so this is okay, this is axis. Okay, from axis actually I just mark. Okay, so this is B1, then O to this D1, then from here to here this is C1, so this is D1, C1, then E1 from the axis. Okay, axis, this is axis E1, then axis to A1. Okay, axis to A1, so this is A1, the same view. So this is the axis line. Okay, so anyway this is the axis line of same length of 50 mm what is given, same length I'll take here. So I'll go for redrawing this view. This is the one, and B1 is the invisible edge, equally spaced equivalent line, dotted line what you call. So this is the visible edge and this is the visible edge. So you can complete the view. So where this becomes A, B, C, D and E. So now in this position I have to draw the view. So this is the position, final position. I have satisfied all the conditions. So the axis is given inclination of 40 degrees. It's not exactly 40, but okay, when you draw that. Okay. So for projecting all the points, could have used the scale. Okay, let it be. No. This is O1, O1. So we'll project B and D, C. In the same way, I'll go from projecting A, then E, then O, then B, then D, then C. Project all the points. So anyway, you draw this with a very thin line, right? Okay. So this is the one. So say C is somewhere here. So this is C, and this is E, and this is D. Okay. So anyway, this is very thick now. I'll go for locating all the points. So A and where is A? This is A and A. So this is A. So anyway, it's resting on B, B1. So B1 is on XY line. So this is B. This is B. This is C. This is D. And this is E. And also you locate O also. I'll not draw that O. And we'll go for drawing that O. So O and O. Let all these lines, what you draw the projectors, let it be very, very thin. Otherwise, see, you cannot differentiate with the views. Okay, I'll go for making it dark, a little bit dark, because it's not visible in the properly. That's why I'm making it dark now. Okay, this is B1. Then this is C1. Topmost is D1. Then so now when you look from the front, in the front view, I can see this A, B, C, D, E, not A1, B1, C1, D1, because I cannot see that surface. You have to pass through that. So we know that all the edges of the end face, which is nearer to the observer, are visible edges. Complete that. Go for the outermost edge. So D1 is the outermost edge with all dashes, because all our front views. Say if I were to mark that, okay. So go for drawing all these outermost edges, and also this outermost edge. Okay. So this is outermost. I'll make it dark. Outermost, outermost. This is outermost. This is outermost. This is outermost. So this is the end face which is near to the observer. Then this end is visible, and this is the outermost end of a line E1 that is visible again. Okay, so always. So you can see A1 is nearer to you and E. So anyway, this is again A1 is, see, the end of this edge and this end of the edge is the outermost point. In that case, I can easily draw that this is visible. I'm not located O1. Say this is O1 dash and this is O dash. So axis line we know how to represent a big dash and a small, big, small, big, small, okay, big, small, okay, in that way. So some edges are not joined now. So that is BC, CD. So then because this becomes surfaces, we cannot have any dark line on that, okay. A thick continuous line, because all this will be on the other side, because there is a surface on this, so there will not be any edge on this. So that may be the edge which are behind, okay. So in that case, go for marking them with a dotted line, invisible edges. So C1 is not joined again. So C1 is a dotted line, because you cannot have a dark line on the end face. There will not be any edge on the end face. So this is your final view, front view. So all dashes, and this is the visible end face, and this is the only three dotted edges, B1, C1, C1, D1 and CC1, longer edge. Okay. The same way I told you, whenever you have any problem saying that is resting on one of its rectangular surface, is resting on HP. So a triangular prism is resting on one of its rectangular, or any prism resting on one of its rectangular faces on HP. Then in that case of the prism, they're going to give you the axis inclined to VP. If the surface is resting on HP or resting on longer edge on HP, the axis will be always parallel to HP. You cannot give it the axis inclination with HP. The axis inclination with VP only will be given. So then you have to just rotate this view, get in only 2 steps, the solution for the problem. So in this case I was satisfied now. See, A1, B1, B is nearer to me. That's why I can see that surface completely. I have turned like this. That's why I have turned it this way. This A1, B1, C1 towards me. So I can see the surface. So I was satisfied all the conditions. That will be the solution for this problem. We'll go for one problem with a rectangular surface when it is resting on one of its rectangular faces on HP in today's class. Okay. I'll check out our problem better. I'll go for one hexagonal. Anyway, drawing all that 6 lines. So there is problem number 26. It says draw the projection of hexagonal prism of base 30 mm side and 50 mm when it is resting on one of its longest edges on HP. The axis is inclined at 40 degrees to VP. One of the rectangular faces containing the longer edge on which it rests is inclined at 30 degrees to HP. Same problem, only with the hexagon he has changed. Okay, so only hexagonal prism has been changed. Okay. We'll go for a problem. Otherwise I can create a problem. Otherwise I'll check out whether it will going to have any rectangular faces. Okay, one of its rectangular faces. Yeah, there is a problem number 9 in triangular prism. For any prism this is the same procedure. An equilateral triangular prism of side 40 mm and axis 60 mm is lying on HP with one of its rectangular faces such that the axis making 40 degrees with VP and the end of the axis nearer to VP is at a distance of 20 mm from VP. So this condition can be satisfied when you redraw. He says one end of the axis is nearer to VP by 20 mm. So I have drawn at some distance in the previous problem. So he says one end should be 20 mm from VP. In that way I can start this point drawing somewhere here because I have drawn at convenient distance. But here I have to fix that point at 20 mm only. I have to draw this axis. In that way I can start my line. In that way I can satisfy that condition. Okay. Otherwise in this problem it was resting on longer edges, so one of its longer edges on HP. So I'll go for any prism, same procedure. When any prism is resting on one of its rectangular faces on HP, even in that case we'll see that the axis will be given only with inclined to VP. The axis will be always inclined to VP because again when it is resting on one of its rectangular surface, axis will be parallel to, it has to be parallel to HP. Then there will not be any inclination with HP, only the inclination can be given is with VP. So you have to turn like this. Okay. So I'll go for drawing this triangular prism. So very easy. So to draw that, XY vertical plane, horizontal plane, right? I told you. So go for drawing the edge of that polygon. Any prism, you construct now prism. In this case it's a triangular prism. If it is a square, go for constructing square. If it's pentagon, construct a pentagon. If it is hexagon, construct a hexagon, right? So that one of that edges of that polygon should rest on XY line. It's nothing but it's resting on one of its rectangular faces on HP, right? Okay, on HP, because when you're looking at the front view, this XY line, so if this the XY line is nothing but your horizontal plane. So this is the horizontal plane because of line thickness, you can assume in that way. So this is your So I'm just drawing like this. Any prism, if I keep this one of the edge resting on XY line, is nothing but it's touching, it's resting on horizontal plane, resting on this horizontal plane, right? So it's a triangle. I'll go for drawing a triangular prism. So equilateral triangle. So bisect any two sides, you'll get that axis. So A dash, B dash, C dash, A1 dash, B1 dash, C1 dash. So O1, the dashes, all are dashes, okay. So in this case there will not be any condition, something like that what is given in the previous problem, saying that one of its rectangular faces contain, because there will not be anything like that. So these are the very simple problem. Any prism, this is the procedure. Go for drawing the base and the height will be given. Take that height and you complete this rectangle. Check out A1, this is A1, this is B1. So it's perpendicular to VP, resting on HP. So it's resting on HP and it's perpendicular to VP, that's why it's a point, right? So CC1 is a point, again it's perpendicular to VP and it's parallel to HP. So perpendicular to VP and it is parallel to HP. See, in VP it is perpendicular, HP it is parallel. So that you can see, because that is the topmost edge, okay. So you can see that edge, so visible. So we know that all visible edges will be drawn with thick continuous line. So this is C1 and this is C, right? Axis will coincide here, so O1, I can put that in the bracket. So it says the axis, now satisfy the condition where it says the axis is inclined at some degrees, so 30 degrees or whatever the inclination given, it says with VP. And again he has given one more condition, that the axis end which is nearer to VP is at 20 mm in front of it. In that case I will go for drawing 20 mm line. So when I draw a line inclined at that inclination, say if I draw a line inclined with that inclination, so some inclination, any inclination, whatever is given, inclined to VP, that inclination, okay. So the axis is inclined at 30 degrees, I'll go for say drawing at 30 degrees to XY line, let me think, okay. So now this becomes your axis. So axis will be here, okay. So this is O1 and O. So then the base will be perpendicular, go for drawing perpendicular, then take this length and transfer here on either side, because both will be same. So go for drawing that, you complete the same view, same length here, okay. So complete that same view which is available.